There is no explicit section in the National Electrical Code, or NEC, that prohibits placing an electrical panel in a walk-in closet. However, there are general requirements that need to be met. NEC 110.16 requires a clear working space of at least 30 inches wide in front of electrical panels. This space should be unobstructed and allow for safe maintenance and operation. NEC 240.24 states that service equipment, including electrical panels, must be readily accessible for inspection and servicing. The inspector may have interpreted the requirement for accessibility as prohibiting panels from being located in closets. However, a walk-in closet with unobstructed access could be considered readily accessible. Commercial buildings, such as multi-tenant buildings, typically have larger spaces and different fire safety requirements than single-family homes. As a result, it is more common to find electrical panels located in closets or other concealed areas in these buildings. While it is generally permissible to place an electrical panel in a walk-in closet that meets the NEC requirements, the following best practices should be considered. Firstly, ensure the closet is large enough to provide the required 30-inch clearance in front of the panel. Secondly, install the panel at a height that is easily accessible for operation and maintenance. Thirdly, avoid hanging pictures or other objects that could obstruct access to the panel. There is no specific NEC provision that prohibits electrical panels from being located in a walk-in closet. However, the requirements for clear working space and accessibility must be met. If the closet meets these requirements, it is generally acceptable to install an electrical panel in a walk-in closet. It is important to understand the NEC requirements for electrical panel installations, especially concerning working space and accessibility. The NEC, or National Electrical Code, serves as the standard for safe electrical installations. One key aspect is ensuring sufficient clear working space around electrical equipment. According to NEC 110.26, sufficient access and working space must be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. This space needs to be clear and unobstructed, allowing electricians and other qualified personnel to perform tasks safely. The depth of the working space in front of electrical equipment is dictated by the voltage of the equipment and the conditions present. For instance, for equipment operating at 150 volts to ground, the minimum clear distance is typically 3 feet. As voltage increases, so does the required depth of the working space. Condition 1 is where there are exposed live parts on one side of the working space and no grounded parts or grounded parts suitably insulated on the other side of the working space. Condition 2 is where there are exposed live parts on one side of the working space and grounded parts on the other side of the working space. Condition 3 is where there are exposed live parts on both sides of the working space. The width of the working space should be at least 30 inches, or the width of the equipment, whichever is greater. This ensures ample room for movement and maneuverability. The height of the working space must be at least 6.5 feet of the height of the equipment, whichever is greater, providing enough vertical clearance for personnel. Accessibility is another critical factor. NEC 240.24 and mandates that overcurrent devices be readily accessible. Readily accessible means capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. This requirement is in place to ensure that in the event of an overcurrent or other electrical issue, the overcurrent device, such as a circuit breaker or fuse, can be easily and safely accessed to disconnect the power. Overcurrent protection devices need to be located where they are accessible and not exposed to physical damage. They should not be placed in bathrooms near easily ignitable material or in locations where they might be damaged. Proper labeling of circuit breakers and panels is also necessary. Each circuit breaker should be clearly labeled to indicate what it controls. This helps prevent confusion and ensures that the correct circuit can be de-energized when needed. The NEC also addresses the requirements for dedicated equipment space. This is the space above and below electrical equipment that must be kept clear of any foreign systems. This dedicated space is intended to protect the electrical equipment from damage and to ensure that there is adequate space for maintenance and repairs. In addition to the working space and accessibility requirements, the NEC also outlines the requirements for illumination and ventilation in electrical rooms. Sufficient lighting is necessary to safely perform work on electrical equipment. Ventilation is important to prevent the buildup of heat, which can damage electrical equipment. Proper grounding and bonding are also crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent device and energizing the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. These requirements are essential for preventing electrical shock and fire hazards. In the context of installing electrical panels, it is important to consider the environment in which the panel will be located. Damp or wet locations require special enclosures and wiring methods to protect the electrical equipment from moisture. Corrosive environments also require special consideration to prevent corrosion of electrical components. When planning an electrical installation, it is essential to consult the latest edition of the NEC and any local amendments. Local jurisdictions may have additional requirements that must be followed. It is also recommended to work with a qualified electrician who is familiar with the NEC and local codes. Ignoring these requirements can lead to unsafe conditions, electrical code violations, and potential liability issues. Proper planning, installation, and maintenance are essential for ensuring the safety and reliability of electrical systems. The NEC is not just a set of rules, it is a comprehensive standard that is designed to protect people and property from electrical hazards. The National Electrical Code serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from hazards. It is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years to incorporate new technologies and address emerging safety concerns. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is a comprehensive document that is essential for anyone involved in electrical work. Understanding the NEC is essential for electrical contractors, engineers, inspectors, and anyone else who works with electrical systems. It provides the necessary guidance to ensure that electrical installations are safe and compliant with industry standards. Many of the NEC requirements are based on established safety principles and engineering practices. For example, the requirements for overcurrent protection are based on the principle that electrical circuits should be protected from excessive current that could cause overheating or fire. The requirements for grounding are based on the principle that all metal parts of an electrical system should be connected to ground to provide a path for fault current and to minimize the risk of electric shock. The NEC also addresses the requirements for specific types of electrical equipment and installations. For example, there are specific requirements for wiring in hazardous locations, such as areas where flammable liquids or gases are present. There are also specific requirements for installing solar photovoltaic, or PV, systems and wind turbines. Understanding these specific requirements is essential for ensuring the safety and reliability of these installations. The NEC is not a static document. It is constantly evolving to keep pace with new technologies and changing safety concerns. The NFPA has a rigorous process for updating the NEC that involves input from a wide range of stakeholders, including electrical contractors, engineers, inspectors, manufacturers, and consumers. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical work, such as wiring methods, overcurrent protection, or grounding. Each article covers a specific topic within that area, such as conductors, cables, or raceways. Each section provides specific requirements for that topic. The NEC is also accompanied by a number of informative annexes that provide additional guidance and information. These annexes are not part of the enforceable requirements of the NEC, but they can be helpful in understanding and applying the code. The NEC is not intended to be a design manual. It provides minimum requirements for electrical safety, but it does not provide detailed design guidance. Electrical engineers and designers must use their professional judgment and experience to design electrical systems that meet the specific needs of the application. The NEC is widely adopted throughout the United States and in many other countries. It is the basis for most state and local electrical codes. Compliance with the NEC is often required by law, and it is essential for obtaining insurance and permits. The NEC is not the only standard that applies to electrical work. Other standards, such as those developed by the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI, may also be relevant. These standards often provide more detailed guidance on specific topics. It is important to use the correct edition of the NEC. The NEC is updated every 3 years, and each edition contains new requirements and revisions to existing requirements. Using an outdated edition of the NEC could result in unsafe conditions and code violations. The NEC is available in a variety of formats, including print, electronic, and online. The NFBA also offers a number of training courses and certifications on the NEC. These courses and certifications can help electrical professionals stay up to date on the latest requirements and best practices. The NEC is a complex and comprehensive document, but it is essential for ensuring the safety and reliability of electrical systems. By understanding the NEC and following its requirements, electrical professionals can help protect people and property from electrical hazards. The NEC is a critical component of electrical safety. It is a living document that is constantly evolving to meet the changing needs of the electrical industry. By staying informed about the NEC and its requirements, electrical professionals can help ensure that electrical installations are safe, compliant, and reliable. There are several key concepts to understand when interpreting and applying the NEC. Firstly, understand the scope of the NEC. The NEC covers the installation of electrical conductors and equipment within or on public and private buildings or other structures, including mobile homes, recreational vehicles, and floating buildings and other premises such as yards, carnivals, parking and other lots, and industrial substations. Secondly, know the definitions of terms used in the NEC. The NEC contains a definitions article which defines many of the terms used throughout the code. Understanding these definitions is essential for correctly interpreting the requirements of the NEC. Thirdly, understand the organization of the NEC. The NEC is organized into chapters, articles, and sections as described earlier. Each chapter covers a specific area of electrical work, and each article covers a specific topic within that area. Fourthly, be aware of the different types of requirements in the NEC. The NEC contains both mandatory requirements and permissive rules. Mandatory requirements are those that are required by the code, while permissive rules are those that are allowed by the code but not required. Mandatory requirements are typically indicated by the use of the word shall, while permissive rules are typically indicated by the use of the word may. Fifthly, be aware of the exceptions to the NEC requirements. The NEC contains a number of exceptions to its requirements. These exceptions are typically intended to address specific situations where the general rule would not be appropriate. It is important to carefully review any exceptions to ensure that they apply to the specific situation. Sixthly, use the NEC in conjunction with other relevant standards. The NEC is not the only standard that applies to electrical work. Other standards, such as those developed by the IEE and ANSI, may also be relevant. These standards often provide more detailed guidance on specific topics. Seventhly, consult with a qualified electrical professional. If you are unsure about any aspect of the NEC, it is best to consult with a qualified electrical professional. A qualified electrical professional can help you understand the requirements of the NEC and ensure that your electrical installations are safe and compliant.